LeetCode challenge, we have 1930 unique 3 length palindromic subsequence. In this question, it says giving a string S, return the number of unique palindromes of length 3. This is important, right? That are a subsequence of S. So they have to be a length 3. Obviously, a palindrome is a string read the backwards is the same as forwards, right? So it says note that if there are any multiple ways to obtain the same subsequence, it's counted once. So we only count like subsequences are unique, right? Palindromic subsequences are unique. A palindrome is a string that reads the same forwards and backwards. A subsequence of a string is a string generated from the original string with some characters deleted without changing the relative order. So if it's ACE is a subsequence of like A, B, C, D, E, right? And I solved this question. I don't think this is the best way to solve it, but I'm gonna do it anyway in the video. So what I did was, so for example, if we take AABCA, right? The 3 palindromic subsequences are ABA, AAA, and ACA, right? So for every single index or character, if the number of like characters to the right of it have to be equal, the frequency, like let's say the frequency of the characters to the right of it have to be equal to the frequency of the characters to the left of it, right? Not necessarily equal, but they have to match. So for the C, there's an A to the right and there's 2 A's to the left, right? So I can form at least one, right? And since they're unique, the length 3 and they're unique, so I can only use one A anyways. I'm never going to use the other A with the C ever again, right? Because they're unique. So making these conclusions for the C, we have an A to the right, 2 A's to the left. For the B, same thing, A to the right, 2 A's to the left. For this A, we have an A to the right and an A to the left, which still works, right? So we need a way to know the frequencies, and for every index, check for this index, for a certain set of characters to the left, do they match in frequencies on the right side? Not match meaning they'd be equal, but can I form a palindrome for some of the characters to the left of me, if they exist on the right or not? That's the question to ask, necessarily. And that's what I did in the solution. So first things first, we made a counter that basically counts like A is equal to 3, B is 1, C is 1 for the whole of the string of S, right? We made this counter, and then we have a current hash map counting the current frequencies we see as we go in this iteration, right? And then I had this set just to avoid duplicates, really. And this is the result we're going to return. So for every index, okay, so this is important. I loop over my current hash map I did. So the current hash map. So for every index, I check the left side, right? And then for every character to the left, I ask myself the question: can I form one? Like, does it have some frequency on the right side that makes me say, okay, I can form a palindrome using this character or not, right? Bear in mind, in this loop, you might see this at first and think, oh, like that's a double loop, but in the constraints it says S is only lowercase English characters, so it's basically only you're looping maximum 26 times, so it's constant at the end of the day. So for every index, right, I loop through the current, so the current character and frequency and current items. So I loop through the current hash map we did, right? And then I have this line which subtracts 1 if S of I equal character else 0. So what this means is, for example, if I'm here, right? If I'm here, and I'm going to loop over the current. So the current is only this, right? So I need to ask myself a question, right? This is the question I need to ask. Is the total frequency of A in the whole string minus the ones I've seen, right? Minus the subtract 1. If it's greater than 1, this asks the question basically, is there any remaining on the right side that can help me form a palindrome here? So I subtract 1 because it's actually equal to the frequency I'm checking. So the current index I'm on, which is A, is equal to the frequency I'm checking currently, which is the A also. So I need to subtract 1, so because these two are taken now. If it was any other character, I wouldn't need to subtract 1. That's why I do the subtract 1 thing. So if the whole frequency of A's minus the frequency I've seen, which is this, minus subtract 1 because they're the same, if it's greater than or equal 1, so that means there's an A on the right side. At least one A exists on the right side, right? And I have not seen this a combination of palindromic sequences before. Yes, add it to the palindromic sequences and res plus equal 1, right? And then update the current hash map accordingly. So it goes like this, keeps going like this, and calculates res at the end of the day. This passes. Not the best, honestly, but it still works. The time complexity for this, though, is O of n, definitely, because this is constant. For a space complexity, possibly also O of n. So yeah, that's been it for this one. Thank you guys, and see you in the next one.